Hi, this is like tutorial 2. So if you've been following on, this is kind of what you would have left off with from the previous one. And we're just going to, continue going a little bit more complicated, step by step. And for today's tutorial, we're going to be looking at a basic like decision tree or behavior tree. Doesn't matter really what you call it. And it's simply a branching structure where you go like left or right, kind of like an if statement. Based upon the results of some conditions. So firstly, let's just design a very simple tree. So that's what we're going to do first. Okay, so now let us actually design that decision tree or behavior tree. So I'm just going to do a quick like mock-up here. And this is going to be our decision tree. And this is what we're going to work with. So let me just make this smaller. Okay, it's going to be a very basic one for you guys to just, start with understanding the concept, the idea. And after we finish, what am I doing? After we finish designing it, what's happening? Why is it not copying? After we finish designing it, we will then actually implement it. So this first one is just going to be the select skill method, and I'm just putting it at the top so you guys know where we're doing this in or how it's working. Okay, so select skill. So when it's like processing the agent, it's going to come into the select skill function, and then it's going to branch down into our actual tree. I don't know why my right click hold is not working. Anyway. And now it's not clicking. Okay, so this is going to be our first little branch here. I should have probably done this in PowerPoint, but it's okay. So that's going to come down into our first actual node. All right, and these are going to be our nodes. And I can actually make this a lot wider. Okay, and then the first node that we're going to do is a simple is closest teammate. Is closest team. And what this is going to do is going to say, okay, well, if we are, so the current agent is the closest agent in my team to the ball, then we're going to do some behavior. So, and that's going to have some sort of outcome, right? So we're going to have a little Boolean outcome here, whether it's true or false. So we have two branches. Now you can obviously have multiple like transitions that have more than two branches, but it'll be implemented in a slightly different way. So we'll have like a yes, and we'll have a no. And based upon that, you'll basically, transition to different states in your diagram. So if we have the right-hand side here being the no, then this left-hand side will be the yes. Okay, and then that will go to another conditional, like a node. Okay, on the left-hand side. So if it's yes here, that means our current agent, whoever is currently processing within select skill, is the closest teammate. So that's good to know because we might want the closest player in our team to go to the ball, for example. But they might not necessarily be the closest player, right? One of the opponents might be closer. So we're going to have another one that says is closest, which is, am I the closest agent to the ball? And that is including both teammates and opponents. Let me just send this to the back just so it looks neat. Why can't I do that? Well, what is happening today with this program? Order to the back. So that would be like the left-hand side one. Now, if I am the closest, what we want the player to do
is, well, I'm the closest of my team to the ball, and I'm well, not necessarily way closer, but I'm closer than all other of the opponents. So by, determining this, you can basically say that, okay, I'm the player with the ball, for example. And by distances that I'm referring to here, it's distance away from the ball. Like, is the closest teammates to the ball. And what we're going to do now is do our leaf. So this is going to go to a leaf. Okay, and the leaves are basically going to be those built-in functions like go to and kick. Serve is busy? What the hell does that mean? Okay. So this is going to be one of our actual, like, you can think of them as actions. And what I want to do here is just kick. So you can use any of those kick methods to kick the ball to the goal. Now, if it is, if this statement is false, or if is closest is false, that means we're the closest player to the ball on our team, but we're not necessarily the closest player to the ball in the game. And what I want to do in that case is dribble. So what this will do, it will walk the agent towards the ball, and then he will want to like dribble the ball all the way to the goal. And this can kind of be utilized as a tackle because it requires our own agents getting close to the ball and then being close to the ball for an extended period of time. So I feel this is kind of okay to use instead of tackle. Cool. So this would be like our left-hand side of this tree over here. So that would be done, right? We would just have to implement these two functions and call these in the appropriate cases when it's yes or when it's no, and we'd be done. So let's deal with the other half. So I'm just going to copy this. Okay, and this is going to be if we're not the closest teammates to the ball, so that means one of our other teammates are closer. What we want to do here is check, are we in possession? So are we in possession? So is possession. And by possession, I mean, is one of our teammates or one of our players closest to the ball? And by closest, I mean closer than the opponents as well. So if we are in possession, but we aren't the player that has the ball, we want to do something like go up the field. Because we're in possession, so we're in like a strong, position. So we can actually go up the field. So this is going to be one of the like go-to targets functions. Don't know why I can't center this properly. Anyway, so this is going to be go up. And I'm just going to have this as when we actually implemented the go-to target function. And this is going to be go back. So this is like, we aren't the closest player to the ball. We aren't even, we aren't the closest teammates to the ball. And our teammate isn't the closest player to the ball either. So the opponent must have the possession. So we should play defensively. And therefore, we want to go back. And this is our basic decision tree that we're going to be implementing. This guy right here. Cool. So now that we actually have that tree, or we've come up with some tree to use, we actually have to obviously implement it. Now that's always going to be the harder part. So I'm just getting some windows around here, sorry. And if you remember from what we've designed, there was that first node that we want to look into. So that node was is closest teammate. So the idea here is we want to check, is our current agent the closest agent to the ball? And in order to do that, we need to implement a function. So each of those nodes are basically Boolean related functions that return a value. So let's do this first one. So it's going to be a bool for Boolean, and that's that like true-false dichotomy. It needs to inherit from the now behavior, just like we have below. And we're going to call it is closest team. And for this, I want to take in the player number.
So the current agent's player number. And we obviously need to use that distance array. So we need to take in a double pointer, which is going to be a pointer to that team distances array, teammates distances array. And that's basically like the header for the function. It's going to be giving us a little error there because we haven't defined the prototype in the headers file. So let us go ahead and do that. I'm just going to put a return false at the very end. But yeah, now we take this guy just like we did last time, and we go to the is it headers? No, now behavior header file. And this is where we were adding our other functions. Gonna copy it in here. I can remove this component here because that's no longer necessary, and everything else plus a semicolon remains the same. Go back to our strategy CC file, and we can get going. Yeah, there we go. That's nice. I don't know what I did to remove the left-hand side thing here. Ah, there we go. Okay, cool. So let's actually get into the implementation. All right, so we're going to need to know a couple things. Firstly, is closest teammate is, so this is going to return the closest teammate to the ball. Return true or false. Return true/false if is the closest teammate to the ball. All right, so we need to loop through that array. So what we're going to do is and find like the minimum distance. So we're going to set a double variable, which is going to keep track of that minimum dist. And because we're looking for the minimum, I want to set this to the max float. Okay. And this is so that at least when you iterating through the loop the first time, the distance will be updated. For example, if I had to just set this to like a big number like 10, right? 10 might end up being the smallest distance, and that's obviously a mistake because we don't have any other agents with that distance. So we don't want it to return 10 at some point. We want it to return the smallest value that's possible. We also want to keep track of the ID of the agent who is the shortest or closest to the ball. And so these are just like some variables that we want to keep track of. If you've done any sort of like looping to determine like min value, these are like the variables that you would have done and utilized there as well. So we're going to say just a for loop quick. So starting from 0 because we're indexing from 0 in the array. And then we want the array length. And the array length will be number of agents, right? Because it keeps track of all the agents, well, all the teammates are stored within this double array. So we can use number of agents. You could also just find the length of this array. That would be another way of doing it, but this is far simpler. Cool. Then we actually do the comparison, right? The check. So if, and we're going to say teammates distances of Z, okay, is less than the minimum team distance, okay. And what we can do is we can then say if this is true, so if our current index is smaller than this temporary minimum value, then we update it. So min team distance is equal to teammate distance at Z. I mean, that's pretty straightforward. And we can say the ID is equal to Z as well. All right, the ID of the agent, which is the closest agent to the ball. Does that make sense? Yeah. Okay. So now what we can do is, oh, this actually doesn't make sense, right? Because if you remember correctly, if we go to headers, I think this will reveal the issue. No, is it not headers? Where would it be? Sometimes I even lose track of where things are. Body model.h? No, it's world model.h. I want to look for where all the other agents are defined. So we need the world model. Is it not this one? World model CC? No, it's not here. What am I looking for? I am looking for the enums for all the different agents, right? And let me just go to one. So I'm going to just come here and then go right click. So this is what I'm looking for. I go to definition. Oh, it was in the world object. Sorry, not world. So here, if I hover over this, teammate 1 is equal to 1. So the actual indexes or IDs for our teammates don't start from 0, it starts from 1. So that's why over here, I'm actually going to say Z plus 1, right? In the array, obviously, that teammate 1 is at index 0, but the ID is 1, so that's why I'm saying Z plus 1. Cool. Okay, so now we just need to finish this function pretty quickly. There's not much left to do here. We just need to compare with our own player number after we found the minimum. So if player number, this is this variable that we receive, okay? If player number is equal to ID, which is the ID of the smallest or the agent closest to the ball. So if this is true, we want to return false. We want to return true. And otherwise, we return false. So I don't have to do the else because this will return out of the function if it's true. Otherwise, this will return, which is exactly what we wanted to do. So there we go. That's the first node done, is closest. Okay, so what we can do now for our tree, we can come in here. And this is like a naive way to do it, but it works. So we can say if, and then we utilize the function. So I'll just copy this. If is closest, then we put it in here, right? Okay, it's giving me an error here because we don't actually have player number like that. We need to remove the typings because that's not what we need. And it's okay. All right. So now if this is true, what we want to do is do the left-hand side of our tree that we defined. Else we do the right-hand side. Okay. Now the left-hand side moved to the node that is closest. So you can be the closest teammate, but are you the closest player overall? So let's just, do that function. So we just got to implement another function. Okay, so that next function is simply going to be called is closest player to ball. So is now behavior once again. I'm just going to copy this because I hate spelling that. Just because it's spelled incorrectly, but it has to be spelled like that. So is closest player to ball. All right. And like I was saying, I might not have implemented these like in the most efficient way, but they're more, it's like a guide. So it's going to take in the player number once again. And it's going to take in both arrays. The first one being the opponent's distance array. how did I spell it actually? Teammate distance, opponent distance. So I'm going to copy this. And that's going to be the first of the arrays that we add in. And then the second one, again, it's a double star. And it's going to be the teammate. And once again, this is going to return a true or false statement. And I'm going to, once again, copy this and make a prototype of it inside an ourBehavior.h. Paste that in there, put the semicolon, and take away this class thingy, that inheritance thing. That's all good there. Save the file. Come here, and it should disappear. There we go. Okay, cool. Cool. Okay, so now we want to basically keep track of two different arrays and the minimum distances between those two. Okay. So what we can say is double minimum opponent distance, and this is equal to max float again. And we'll look what is the minimum distance for the opponent array. So the idea here is that you check what's the minimum distance or the ID for the minimum distance for the opponents, and you do it for the teammates, and then you check, well, is my distance smaller than all of those distances? And if so, then yes, I am the closest player to the ball. Okay, so we need this one. And we're going to do another for loop to go through all of the opponent agents. And this is going to be int z, starting from 0, z, I don't know why I chose z. My muscle memory is telling me to go for I, and z++. And remember, it's less than number of agents, which is 2 in our case, but it, depending on number of agents, it'll be more or be less. Cool. So now we do that that if statement once again. So a lot of this code is it's like repeated because it's kind of solving similar problems. So again, you might be able to reuse other functions to perform these tasks. This is just like the most obvious way I found to implement it. Didn't really think too hard about optimization. Because it's not super necessary at this point. So if the current opponent distance z is less than this temporary variable that we comparing to, well then I need to change the distance again, right? I need to update this minimum of distance to be our opponent distance z. Exactly the same as what we did for the previous one, all right? And then we can basically copy this code here because it's what we want for the teammate side of things. And all I'm doing is the teammate aspect as well. So this is the minimum distance in the opponent distances array, and this is the minimum distance in the teammate distances array. Okay. Now, if the opponent distance is smaller than the teammate distance, obviously one of the opponents is closer than one of the teammates. So then this should return false because I'm definitely not the closest player to the ball if none of my teammates are the closest player to the ball. So if this is the case here, then we should return false. Okay, now the else condition basically is where now we know we're the closest team to the ball, but we don't know which agent specifically is the closest. So we got to compare our distance with the minimum distance, and if those distances are the same, then we know we are the closest player because that minimum team distance must be myself. So if min team distance is equal to teammate distance, and this is my looking at getting my own distance, and that's why we had the p number, pnum. But remember, pnum indexes from 1, right? Starts at 1, so we have to subtract 1 here to get the correct representation within that array. So if this is true, where I am basically the minimum distance, then we return true, like such. Else, we return false. Okay, pretty straightforward. So that's the next one, right? We've done this next function, and all we got to do now is basically call it. And this was if the yes was the case in terms of is closest team. So if open brackets is closest team, all right, that's the next like branch in our tree, and then pnum is actually player number in this case, and we can remove the typings here like such, and yeah, there we go, it's not complaining. All right, so that's if we went left again, like if we went yes. So now if this is true, we have two conditions, if it's true and if it's false. All right, so if this is true, we said that, okay, we just want to kick the ball towards the goal. So I'm just going to copy that code here, and it's this one. All right, so if that was true, then we want to kick the ball to the goal. Okay, if it wasn't true, we wanted to just dribble the ball to the goal. So with using the dribble, we know we're going to go towards the ball and basically contest it a little bit, like in a way tackle, like a very like naive tackle approach, because we're just trying to kick the ball a little bit all the way to their goal. And if an enemy is closer, they'll be doing something, but we might be able to block it by going towards the ball. Okay, so that was that whole left-hand branch from is closest teammate all the way down to all the leaves. Now let's look at that other side where it's going to say we aren't the closest team. We aren't the closest teammate. Okay, so we could still be in possession, but we aren't the closest player to the ball. And we definitely aren't the closest player within our team to the ball. So let's look at that if that else component. And that requires implementing that last function, which was, are we in possession? So if is possession is the function that we're going to be defining. So once again, now behavior your : is possession. Okay, I think I spelled that correct. And it's going to just take in the two arrays. And this function is basically just the first part of the secondary function here. This is closest player to the ball. Because again, it's doing similar things in a slightly, but solving a slightly different problem. So I'm going to copy this entire guy here. I'm going to say go to now behavior. And I'm going to remove this one and that and semicolon. Cool. There's the prototype. This little zigzag line will go away, and that's what we want. Now, what I want to do is just copy these two. Okay. And you remember these two, like for loops, were for determining whether or not, for determining which was the minimum distance for the opponents and for our teammates. Okay, so now I'm also going to copy this if statement here, which is comparing the two final distances or min distances. And is possession will say, like, is my team in possession or is the enemy team in possession? So the idea here is that we're in possession if, okay, our distance, our minimum team distance is less than the opponent's minimum team distance. All right, and if the minimum opponent's team distance is less than, then we aren't in possession, so we should return false. Okay,
and return true if that's not never the case. So we come here, and that's it. Like pretty quick function to implement because we had done all the work here. Cool. So let's just call this function now. And we are going to call it over here on this else side. So it's if is in possession. Okay. And I can remove the types once again. And just make sure that you've substituted in the right parameter in the right place, because if I had to swap these, then obviously I'll get a different result. It'll be the opposite. So you got to keep track of that. Okay, so if is in possession is true, then we want to go up the field, and if it's not true, we want to go back down the field. So this is an if else once again. Cool. So how we can do these is we can just go, we can use these functions here. And just basically change the X value. So we're going to say go to target relative. If we want to go up the field, which will be the case when we are in possession, and we want to go backwards here if we aren't in possession. And we return these. So again, this is a very naive little decision tree, but it's one that can work, and it's one you can build off of. So what I'm going to do is I'm going to run this and see how effective it is. So we come to our side here, and remember we got to make everything over again. Ugh, I got to get a CD into it. Where is this file though? Is this the one? Might be, I think so. So it's going to take a little bit longer than usual because I haven't even saved all my files. So you see it says one unsaved there, so always just watch out for that. I'm going to go save all. Going to come here, going to go make. That's a little concerning why I did it so quick. I think I might be in the wrong folder. So let me just figure that out quick. Yeah, there we go. How can we see which folder this is? File, open folder. I think it's in the RoboCup AI folder that we need to go into. So ls cd RoboCup RoboCup AI. RoboCup source. Why is RoboCup AI not showing? Oh, it's lowercase c. Okay, and then cd the UT Austin Villa. Unless that make. Hopefully this is the correct folder. I have too many different folders with the same names, so I can lose track of it. Okay, this is building a few more things. I see it's building the now behavior, which is something we changed a bit by adding all those additional prototype files. Now, while that's busy, and I know the changes I'm going to be making now won't affect anything, but what I want to do is do some like visualization stuff, just to like demonstrate how you can use the RoboViz visualizer a bit better. And what I'm going to do that is I need to get my position because I want to start drawing circles around. I want to draw some circles around my player. Okay, so in order to do that, I want to get a vec position that represents my position. I don't know, did I already do that? Oh, I did already do that. Okay, perfect. So I don't even need to do that. Let us just draw some circles then.
So in order to draw circles, well, we use the draw circle function. Okay, and I'm just going to copy this in and I'll step through it with you. So for each like leaf, we want to draw a circle. So I copied this in as a world model, get RV sender, okay, then draw circle. You see the other time we use draw text, we're just using draw circle now. It takes in a name, okay, the name of what you want to draw, and I'm going to just use that SPNum, which is just a string representative of my player number. So let's make that up, and I'm going to put this over here. So it's just standard library string SPNum is equal to standard toString pnum, which is going to be our player number. Okay, that's just converting an integer to a string. Again, cool. And now my pos, why is it unhappy with my pos? Capital P, lowercase p. Cool. So is this finished? It is. Okay, so now I'm just going to run the previous thing that we were working on before I go too far into that. Server, is the server running? It is. So we're going to go start.h. I'm just going to type it. Start.sh. ./start.sh, sorry. What? ls? Starts. I'm so blind today. And in this one, I need to also cd into that file. So I'm just going to open this and say open a new tab when it gives me the chance. Okay, and this will be start2.sh. Cool, team2. Hopefully that's the right name. I can't remember. If I go start2.sh, it should be team2. Okay, so we are in the right folder. So that's perfect. All right, now if I do kickoff left, these were all those distances that we had from the previous tutorial. It's all the different play distances. And now hopefully when we get running, we'll get some interesting behavior. Everyone stands still. And that makes sense actually because of one little thing that I forgot to comment out. So we're going to kill the server. And if you remember how we ended things last time, I returned skill stand here. So it's not even going to come into this because of this guy. So I'm going to just comment that out because we don't need it anymore. And yeah. And I'm just going to remake things quick. Actually, because we got this in, let's just finish with the drawing. So if it's this one, like if it does the kickball, I want to draw a red circle. And if we're going to do the dribbling, I want to do like a different colored circle. So let's do like a yellow circle. So I just need to add another 1 here. So this is red, green, blue, so it's 1, 1. This is the radius of the circle. And this is your RGB values. And this is yellow. Cool. I'm going to do the other 4 leaves now, or the other 2 leaves. And what I want is some other colors. We can have cyan or, well, I mean, let's just do the basic ones. So this would be blue if I just do blue there. Sorry, green. And the last one is going to be the blue one, which will be RG and then the B. Cool. And these range from 0 to 1 values. So that's like, if I wanted to change this, I would do like 0.5 if I wanted to do something. It doesn't range from like 0 to 255. So that's something to realize. It's 0 to 1. Okay, I'm just going to doubly show you. I don't have to save all because we're all good. And this is all ready. So now I go to my server, start my server again. Make my agents No, that's ls, not make. Make my agents wait a little bit, won't be too long, and we can finally do the little demonstration, and I hope it works. But if it doesn't work, then I can actually show you how to debug some stuff. But I have a feeling it might work. So start.sh, start.sh2 or start2.sh. Come over to the visualizer. Our boys are ready to play. I'm gonna just make the window a little bit bigger. And we're going to be turning on the drawings, but that will happen already anyway because I saw last time. So kick off left and let's see what happens. So hopefully it draws our circles and stuff happens and we want it to happen in the correct way. Cool, there's our circles and you can see the different behaviors at work. Now there's a free kick right, so they're just doing the behavior tree anyway, I think. Actually, don't know what behavior we incorporated for free kick. Anyway, play on's back, so now it works. And you can see the circles like moving around a lot, once again, because it's that localization thing where the players don't know what, because they're using that computer vision technique, they're struggling to see, because they're falling over and like getting back up, they haven't like localized themselves in the world. So it's a lot harder. I just want to make this smaller, maybe like maximize it over here. Close this quick. And we can, how did I minimize this before? There we go. So if you remember correctly, the green circles just go upfield, right? And that's what's happening. And the blue circles go back. So as soon as you see a blue, they should be walking backwards. This guy is walking backwards. We actually scored a goal, which is pretty good. The red is going to be kick, and the yellow is dribble. So the yellow happens when like two agents are fairly close to each other, like from the opposing team and my team. So he's going to go block now because he's dribbling. The free kicks is something we need to consider, but we're not doing that at the moment. Okay, I gotta wait for it to go back to play on. Cool. So yellow, he's gonna go dribble the ball. Red means he's closest to the ball and he's gonna kick it. And now there's two agents pretty close, so they're both dribbling. Green, they both think they should go upfield because both their agents are fairly close. Now, red is concerned a little bit, but you can see how the behavior is changing. Because we use just forward, right, which is not like super good, he's just walking forward, right? And it's walking forward relative to his position, so he's just going to carry on going that way. Cool, but that's basically all I wanted to demonstrate in this video, how to like get that decision tree thing going. We also implemented a few more functions that actually make use of these distances. But that's going to be it for today. I hope this makes sense. Please, if there are any questions, let me know. But otherwise, you should be kind of happy.